Welcome everybody once again. So we are studying about open channel flow. We have already studied what is open channel flow, what are the types of flow. We saw what is Chassis formula. Then we saw the basins, cutters and Mannings, the empirical formulas for determining the Chassis formula, Chassis constant, for the determination of Chassis constant. And we saw some problems related to this. That is how to find the discharge flowing through a channel. So now, after that, we saw the most economical channel sections. And the condition for most economical channel section was the wetted perimeter should be minimum. And under most economical channel sections, we saw for the most economical rectangular section, the conditions are the breadth is equal to 2 times the depth of flow. Small d means the depth of flow. So breadth of the channel should be equal to 2 times the depth of flow, and the hydraulic mean depth is equal to half of the depth of a flow. So d by 2. So these are the two conditions for the most economical rectangular section. Then we saw for the most economical trapezoidal section, see when you take a trapezoidal, this is B and the top width will be B plus 2nd. And the sloping side will be d into square root of 1 plus n square. So for the most economical trapezoidal section, the conditions are, we saw three conditions. Condition 1, condition 2 and condition 3. So condition 1 is half of the top width, b plus 2nd by 2, half of the top width is equal to 1 of the sloping side. Okay, so b plus 2nd by 2 is equal to d into square root of 1 plus n square. The second condition is hydraulic mean depth is equal to half of the depth of flow. So m is equal to d by 2. And the third condition is when you draw a semicircle with the center at the mid of the top of the width. If you are taking the center of the top, see this is the top width. If you are taking the center of the top width, you take this as a center, and if you draw a circle, okay, if you draw a semicircle, see this circle will meet the three sides of the trapezoidal channel. It should meet the sides and it should meet at the bottom also. So a semicircle drawn with the center at midpoint of the top width and radius equal to d. Okay, this is the center and radius should be equal to, this radius should be equal to small d. So radius equal to d will touch the three sides of the trapezoidal section. Actually it is this. So up to this we saw in the previous class. Now some more important points to remember, or some more important points which you should know before solving the problems. See, I am not giving you any more derivations. We saw the derivation for all these conditions for the most economical rectangular section and for most economical trapezoidal section for these three conditions. Now remaining things I am not giving you the derivation, just the conditions alone. If you want the derivation, you can refer the book, but your exam point of view, this is enough. So the next condition is the best side slope for most economical trapezoidal section. Again, for the trapezoidal section, for the most economical trapezoidal section, we know there will be a side slope, right? So if this is a trapezoid, see this is called, this you take it as theta, this is called side slope. That is the angle made by the sloping side with the bottom. That is called theta. So for the best side slope for the most economical trapezoidal section is theta is equal to 60 degree. So this theta will be equal to 60 degree. So the best side slope is at 60 degree to the horizontal. So the side slope should be 60 degree to the horizontal. Now for the slope of 60 degree, the length of the side sliding slope will be equal to the width of the trapezoidal section. So if theta is equal to 60 degree, this side slope will be equal to the depth. Sorry, not depth, the width. Side slope will be equal to width of the trapezoidal section. Okay. Now, so that is all. So these things you should remember while analyzing a trapezoidal section. Okay, for the most economical trapezoidal section. Now, flow through circular channels. Next is the circular channels. So, the important things to remember is, see, consider a circular channel. This is your cross section of your channel. So, the cross section is circular, and this point O is the center of your circular section, and you can take the diameter as capital D. Okay, the diameter can be taken as capital D. Now, the radius is taken as capital R. Now, if the depth of flow is below the center, if the depth of flow is like this, so small d is taken as the depth of flow. So, this is the depth of flow of the channel. So, you can mark the points A and B. When you draw lines from A and B to meet at the center point O, this angle is taken as 2 theta. Okay, this angle is taken as 2 theta. So, half of this will be theta. So, this is 2 theta. So, if you draw a perpendicular, if you draw a line perpendicular to AB, you will get this as theta and this angle as theta. Now, so if this is 2 theta, our hydraulic mean depth M will be equal to A by P. So, before that, come for area. So, area of the channel, area of the water flowing in the channel. Okay, area of the channel will be equal to, in open channel flow will be equal to area of ADBA, this portion. Okay. So, area of ADBA will be equal to, see, there is a derivation. So, I am giving only you the important results. So, area will be equal to R square into theta minus sine 2 theta by 2. You have to remember this. You have to by heart this, remember this. Area is equal to R square into theta minus sine 2 theta by 2. And the wetted perimeter P is equal to, see, this distance is equal to, we know the radius is R. So, R into 2 theta. So, this perimeter, this distance ADB will be equal to 2R theta. So, that is your perimeter. Okay. So, area is equal to R square into theta minus sine 2 theta by 2 and P is equal to 2R theta. So, substituting you get M is equal to A by P, that is R by 2 theta into theta minus sine 2 theta by 2. You should remember these things. Okay. So, you remember this area and perimeter, you can wetted perimeter, you can easily find the hydraulic mean depth. See, this is for the circular cross sections. Now, for the most economical circular cross sections, you have two conditions, two cases. First case is the condition for maximum velocity and the second case is the condition for maximum discharge. So, for the condition for maximum velocity, the condition is 2 theta is equal to, you know what is 2 theta? It is the angle subtended from A and B towards the center. This is 2 theta. So, this 2 theta is equal to 257 degree 30 seconds. And so, therefore, theta will be equal to 128 degree 45 minutes. This is 257 degree 30 minutes. And the depth of flow should be equal to 0.81 times the diameter of the circular channel. So, D is equal to 0.81 D. This is, and M, that is hydraulic mean depth, is equal to 0.3 D. This is the condition for getting the maximum velocity for a circular channel. Now, case 2 is, so 3 conditions. Okay. So, case 3 is the condition for maximum discharge. 2 theta is equal to 308 degree. Therefore, theta should be equal to 154 degree. And the depth of flow should be equal to 0.95 times the diameter of the channel. So, these are the two conditions for the maximum discharge. So, for your problems, if you are asked to find the maximum discharge, maximum velocity, economical sections, then you have to use the conditions which you have studied for the economical sections. Okay. Now, we will move on to our problems. Just 2 problems today. So the first problem is, so these problems are for the most economical rectangular sections. So the first problem is a rectangular channel is of width 4 meter. Okay, the rectangular channel is of width 4 meter. Sorry, it's an open channel flow, right? Okay, width 4 meter and is having a bed slope. Bed slope is 1 in 1500. So our B is given as 4 meter. I is given as 1 by 1500. Find the maximum discharge through the channel. See, if it is the maximum discharge, you have used the most economical conditions. Now take the value C is equal to 50. Chassis constant is given as C is equal to 50. So we know the condition for a rectangular channel, most economical rectangular channels, the conditions are B is equal to 2D, right? B is equal to 2D and M is equal to D by 2. So by taking B is equal to 2D, from this we get D is equal to B by 2. So B is 4, 4 by 2 we get D is equal to 2 meter. Right? So D is equal to 2 meter. Now we know for the most economical channel M is equal to D by 2. So we get M is equal to 2 by 2. Therefore M is equal to 1 meter. Hydraulic mean depth is 1 meter. Now we know what is the discharge. So discharge will be equal to area into velocity. So that is area B into D multiplied by velocity. We will use chassis formula C into root of mi, from which we get Q is equal to B is given as 4 meter, D is 2 meter, C is constant is given as 50, chassis constant, into square root of M is 1. So 1 square into I is 1 by 1500, from which we get Q is equal to 10.328 meter cube per second. Okay, now we will move on to the next problem. So second problem is a rectangular channel carries water at a rate of 400 liters per second. So Q is given as 400 liters per second. Converting it into meter per second, you divide it by 1000, we get 0.4 meter cube per second. When the bed slope is, so the channel is a rectangular channel and the bed slope is 1 in 2000. So I is given as 1 by 2000. Find the most economical dimensions of the channel if chassis constant C is 50. So you need to find what is B and what is D. So we know, see we know for the most economical conditions, the conditions are B is equal to 2D and M is equal to D by 2, right? So we know Q is equal to area into velocity. So area is B into D into velocity is C into root of mi. So Q is equal to, we don't know B. So first of all, I think we will find D. Okay, so B is equal to 2D multiplied by D into C is given as 50 into square root of M is, we know for the most economical condition it is D by 2 into I is given as 1 by 2000. So Q is given as 0.4 meter cube per second. So 0.4 is equal to 2D square into 50, right? So we get 100 D square into square root of D by 4000. So the only unknown is D, from which we get D is equal to 0.577 meter. So if D is 0.577 meter, we know B is equal to 2D. So B equal to 2D. So that is 2 into 0.577, from which we get B is equal to 1.154 meter. Okay. So that is all for the most economical rectangular sections, problems related to most economical rectangular sections. Tomorrow we will see the problems related to most economical trapezoidal section in the next class. So thank you. Hope you understood. Thank you for today. Thank you for listening.